The mass number of an atom is equal to the total number of protons and neutrons in its nucleus. So in this diagram of a nucleus, we have 3 neutrons, represented by the plain green circles, and also 4 protons, represented by the blue circles with a plus sign. Then the mass number is the total number of protons and neutrons. In other words, the total number of circles in the diagram. 3 plus 4 is 7, so this diagram represents a nucleus with mass number 7. But how does a mass number relate to atomic notation? Well, in atomic notation, the top number is the mass number of the atom. For example, let's consider the notation for this beryllium atom, which has the nucleus in the diagram we just saw. So this top number, the 7, represents the mass number. Then with this, we can find the number of neutrons by finding the difference between the atomic and mass numbers. Remember, the bottom number in atomic notation represents the atomic number, the number of both protons and electrons in the atom. So in this case, the 4 tells us that there are this many protons in the nucleus. Therefore, the number of neutrons is found by doing 7 minus 4. We take the total number of protons and neutrons and subtract the protons from this, to find that there are 3 neutrons. For your exams, make sure you can distinguish between the 2 numbers used in atomic notation and that you can find the number of neutrons using these. In this notation, the bottom number tells us what type of element we have. But what exactly is the top number telling us? Isotopes are atoms with the same atomic number but different mass numbers. Let's see what this means by looking at these 2 nuclei. We'll call the one on the left X and the one on the right Y. Both of these nuclei have the same number of protons, 4, so we can write the same atomic number for both. But on the left, we only have 3 neutrons, while on the right we have 4. This means that X has an atomic mass of 7, while Y has a larger mass of 8. So overall, X and Y have the same atomic number, but different mass numbers. So these are examples of isotopes. Also, as the atomic numbers of isotopes are the same, they are of the same element. In this case, since both nuclei have an atomic number of 4, they will both be beryllium nuclei, even though they have different masses. So with these properties in mind, what will be the same and what will be different between isotopes? Isotopes will have the same chemical properties, but can have different physical properties. Here, by chemical properties, we mean the types of reactions it goes through and bonds it forms. If we look at the full atoms of our previous isotopes, we see they have the same electron arrangement. This is because atomic number also determines how many electrons are in an atom. So because both isotopes have the same number of electrons in the same shells, they will react chemically in the same way. You should be aware of this for a physics exam, but this is something you'll learn more about in chemistry. Then by physical properties, we mean things like density and radioactivity. These are all determined by the nucleus of an atom. So since the isotopes have different nuclei, these properties could be different for them.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!